Let's take a look at the R combinations from a different perspective that will help us understand how to count these R combinations without having to list every one of them every single time. So let's suppose you're playing a game. So you have a dartboard that has the numbers 1, 2, 3, 4, and your goal is to throw darts at this board and see where they land. So you have 2 darts available in your hand. Okay, let's suppose you are playing the game right now and you throw the darts. Well, one possibility is that one dart lands in 1 and another one lands in 4. Okay, again, it doesn't matter which one landed where first. You would understand the numbers at the end were 1 and 4. Okay, so that's considered as a multi-set. If I play the game again, suppose I have 2 more darts that I throw at the board. Again, I reset and I play again. So this time my first dart lands in 2, my second one lands in 3. So my multi-set is going to be 2 and 3. Let's play the game 2 more times. And let's suppose this time that your 2 darts both landed in 1. Then you would know that the multi-set is 1, 1. And suppose your 2 set or your 2 darts landed in 2 and 4. Then you would know that your multi-set is 2 and 4. Again, 4, 2, 2, 4 does not matter because in this section, the order is not that important. Okay. Now, instead of drawing all the colors and all the darts and everything, here's what I'm going to do. I'm going to take a look at this first example and just kind of eliminate the numbers and eliminate the colors and everything. If I wrote x / x, would you understand that this is the same thing as x / x? Can you kind of come up with the combination 1, 4 by looking at the x's and the slashes? I hope you can. So let me explain it again one more time. What about look at the second problem? We had a slash, then we had an x, then we had a slash again, then an x, then a slash again one more time. So that's kind of like the combo 2, 3. The third one would correspond to 2 x's and then 1, 2, 3 slashes. Okay, and finally the last example that we made together would correspond to slash x slash and then x. So by looking at the location of the x's and the slashes, I can pretty much understand what the multi-set was equivalent to. So like for example, if somebody wrote x / x / what would I understand? Here's what I would understand. I would imagine that there's a dartboard with 1, 2, 3, and 4, and I would understand that the first x landed at in 1, then there were 2 slashes with emptiness, and then the second dart landed in the space that's after the second slash, so that's basically 3. So I would understand that the multi-set was 1 and 3. Okay. Now, why do I bring up this slash and x method? So I bring it up because the actual theorem in this section will rely on kind of counting how many x's and how many slashes there are in the problem. Okay. So in this particular problem, my dartboard had 4 groups, 4 options if you want. Okay, so 4 options, 4 goals or groups or locations. And in my case, I had 2 darts plus 2 darts. Okay, or in other terms, 2 choices. I had to make 2 choices. Okay, so according to the formula, all I have to do in the future to figure out how many multi-sets there are of 2 from 4 is calculate 4 plus 2 minus 1, choose 2 because I'm making 2 choices. And in this case, that will turn out to be 5, choose 2, which is at the end 10, which is the desired number. That's how many we calculated when we actually worked out the whole problem. So at the end of the day, all I have to do basically is figure out how many goals there are or how many groups there are. You know, this normally corresponds to if I'm buying sodas, how many types of sodas are available. If I'm buying donuts, how many types of donuts are available. And the number 2 that we have down here corresponds to how many selections I'm supposed to be making, right? Am I choosing to buy 2 cans of soda or 10 donuts or whatever? That's going to be the number that we write down on the bottom. So in the formula, that number is going to be called R, And in the formula, this number is going to be called n. So n is 4 and r is going to be 2. This is the formula. It's called theorem 9.6.1. So again, to count how many r combinations there are, figure out what the size set is. It's n, and then add n plus r minus 1, and then choose r. Why do we need the minus 1? Remember in the last example, we had 4 different, spots, but how many slashes did we need to separate them? We only need actually, 3 slashes to separate 4 different groups. We don't need the one at the beginning and the one at the end. So those ones are eliminated. We only needed 3 dividers, basically. That's the reason why we have to subtract 1 every single time, okay? So let's take a look at an actual example. It says a person is throwing a party and he wants to buy 15 cans of soda for his guests. He shops at a store that sells 5 different types of soda. So how many groups do I have? There are 5 groups of soda. Okay, maybe Dr. Pepper, maybe Sprite, whatever. There's 5 of those. And how many does he have to buy? He has to buy 15. So this is how many choices he has, 15 choices. He has to buy 15 cans from 5 different groups. So in my problem, the groups would be the little slashes or dividers, and the x's would be the 15, the choices basically, okay? So the question here in this problem is, well, how many different selections can he make? So he can make, according to the formula, 5 plus 15 minus 1, choose 15. That's the answer. So the formula would tell me that n is 5 and r is actually 15. And the total is 3,876. So this is how many different choices he can make. Basically, this is how many selections he's got of the 15 different kinds of sodas that he's buying from the 5 available groups, or. All right, suppose that Dr. Pepper is one of the types of soda. How many different selections include at least 6 cans of Dr. Pepper? Okay, so let's figure that out. So let's say he's got choices. So there's Coca-Cola, let's say, and there's Sprite. Let's say there's Fanta and Dr. Pepper. And we need one more. How about we say, okay, the last one will be, let's say Pepsi. Okay, so the person wants to buy at least 6 cans of Dr. Pepper. So he has to select right off the bat 6 cans of Dr. Pepper and maybe more. Okay, now how many choices does he have in total? In other terms, how many cans of soda is he planning to buy that day? Well, he's planning to buy 15 cans of soda at the end of the day, but 6 of them or more have to be from the Dr. Pepper. So let's suppose he buys those 6 cans of Dr. Pepper, and now how many is he gonna have to buy in addition to that to get to 15? Well, he has to buy basically 9 more cans of soda. They could come from the Coke, they could come from the Sprite, they could come more again from the Dr. Pepper, they can come from the Fanta side, they can come from the Pepsi side, who knows? But basically, what does he have? He's got basically 9 stars, and he's got 1, 2, 3, 4 slashes. In other terms, what he is dealing with is this. He can make, this time there are still 5 groups of soda: Coke, Sprite, Fanta, Dr. Pepper, and Pepsi. However, he's no longer choosing 15 cans of soda. He's only choosing this time 9 cans of soda, because the 6 have been predetermined. They have to be Dr. Pepper. And then choose 9. Okay, so does that make sense? And their total is going to be 715. So again, it decreases because he's limited this time in his choices. He has to choose 6 Dr. Peppers. Okay, so again, the idea is, since the person has to select at least 6 cans of Dr. Pepper, then what remains is 9 cans of soda that have to be selected from the different options available at the store.